Here's our container, and it's really settled down. I don't know if you can see, it's not that cloudy as it used to be, and all the deposits just on the bottom, so there's no yeast in our mesh no longer. Everything's just located in the bottom, and our steel and all the setup is ready. So we've got mesh, we've got our pump ready, pump connected to the steel. Here's a control valve. So to run the steel, first of all you need to make sure that water is on and supply it into the water distributor, and here you can see the level in the steam generator. So that's the first must thing, water connection. The second thing that we're gonna do, we're gonna switch on the pump. The pump is on, and we're slowly opening the mesh supply. So as you can see, the mesh went through the tubing to the steel, and here's the level. So we're gonna fill the steel up with the mesh, I mean the top section. The level is coming up, so now we're closing down the tap. Our mesh flow control valve is closed, and we're switching on the steam generator. The pump is still running, it's okay. Now we're gonna wait when the steel is getting hot, so it's gonna take about 5 minutes to preheat the steel. Is the first ethanol that coming out, and actually it indicates that steel is preheated. It took no longer than 5 minutes, so actually the top part of the heat exchanger is gonna become quite hot. So this is the time to open up the control valve and let the mesh go through the steel. So the control valve is opened. You have to control the flow of the mesh the way that it would make the low part of the top section of the heat exchanger a little bit warm, not really cold, not really hot. The lower part, the top part is still hot. The very low part of the heat exchanger is cold because there's cold water circulating in here, and the production speed should be around 3 liters per hour, so it's around 50 milliliters per minute. The production speed though could vary depending on the actual ethanol amount or alcohol contents in the mesh. So the higher the percentage in the mesh, the faster it can go. Technically it would go somewhere around 3 liters per hour all the time, but the final result, the percentage of the raw spirit will be different. So here you can see the spirit production. It's a raw ethanol. It's a little bit cloudy, and just repeating one more time, this steel is not a steel for the production of the food grade ethanol, but for the production of crude ethanol that will be redistilled, refined and purified in fractional steel. So this steel is just a time saver. It allows you to distill big quantities in almost no time, because it's only 5 minutes of preheating. You can switch it on anytime you need it, you can switch it off anytime you need, leave it, you know. So there's no like with a big pot steel where you have to be with the steel for the whole period of distillation, have to wait hours and hours when it starts to produce. So technically this steel will process these 20 liters of mesh during the time that for the pot steel, for example, would take to make it boiling only. So it's a steel for crude ethanol production, for mesh processing, and it's not steel for production of food grade ethanol. I wouldn't recommend to drink this stuff to anyone. It's not poisonous. I would say it's a pot steel quality, but I'm personally never been trusting to pot stilled spirits. Here you can see percentage is around 38% at 20 degrees Celsius. It's not that high. Today we're processing just 8% mesh. It contains only 8% of alcohol. We just didn't have time to wait till it's get any better. Just because of this video, wanted to test the steel to show what it does. So this ethanol at this percentage will be loaded to the fractional steel without mixing with any water or whatever, and then we're gonna see what we're gonna get after the fractional distillation.